Man, there's so much traffic out there. You know, I've been thinking, with all these cars out there, we should do something to get rid of all the CO2 they're putting into the atmosphere.
Well, what uses CO2? I mean, I was reading in biology book here that the carbon cycle, right? Don't plants use the CO2?
That's right. Plants take up CO2 that we breathe out, and they give off oxygen?
Yeah, I think that's right.
Yeah.
But how many trees would you need to absorb all of the CO2 produced by cars out there?
You know, that's something we're going to have to look into. How much CO2 do you think the cars in our city actually put out?
Well, first, I guess we'd have to figure out how much driving is actually done. I guess we could say that maybe there's 1 million people driving cars each day to work or something like that.
And people only go to work 5 days a week, so...
Right. So 5 days a week out of 52 weeks a year.
So that way we could find out how many people are driving their cars in 1 year.
Yeah. Yeah.
But how much CO2 does a car put out?
Well, cars burn gasoline, right? And gasoline contains carbon.
Right.
And when you burn it, the fuel gets converted to CO2, right?
Yeah.
So how much CO2 gets emitted from burning 1 gallon of gasoline?
I could go look it up.
Yeah, that'd be good.
All right. Okay, well, I looked it up, and I figured out that a gallon of gasoline gives off 8.2 kilograms of carbon dioxide.
Okay, so we can combine that with maybe saying that they use 1 gallon on each trip to and from work.
Okay, that sounds reasonable.
Yeah.
But how would we know how many trees we would have to plant to get rid of all that CO2?
I don't know, we may need to think about that one. Have you thought about that problem that we were talking about yesterday at all?
Yeah, I did. I actually looked up a lot of stuff that I think will be useful for us.
Oh, good, yeah. I mean, I think we made a good amount of progress on thinking about how much CO2 is produced in a year. But how do we get an idea of how much CO2 is absorbed by a tree in a year?
Well, I think we have to start from the basics. Like, a tree starts out as a sapling, right?
Yeah, yeah.
So a good sapling that you would plant is probably 3 feet tall and 2 inches in diameter.
Yeah, that sounds reasonable. And then you can just consider a tree just simple as like a cylinder then, right?
Right, because it wouldn't have many branches as a sapling.
Right.
So, but how would we calculate how much weight is in that cylinder of a tree?
Well, you'd have to know something about the density of the tree.
Oh, I looked that up. I thought about wood floats on top of water, so it must be less dense than water. So I actually found out right here in my notes. It's 0.7 grams per cubic centimeter, the density of wood.
Okay, so you could use that to calculate the weight of the tree.
Okay.
Yeah, but aren't we forgetting about something? Aren't there? What about the roots that are below ground on the tree?
Oh, well, how much root do you think there is for a whole tree?
I'm not sure.
I would say, from all the plants that I've seen, for however much tree is above ground, if there's 1 gram of tree above ground, there's probably 0.2 grams of root below ground.
Okay, yeah, that makes a lot of sense.
So is that all we need to consider when thinking about the weight of a tree?
Well, is the whole weight of the tree carbon, or is there anything else in a tree?
That's true. I think I also looked that up. I think the dry weight of a tree, which would be the carbon-containing material, is actually only about 3/4 of the whole weight of a tree. So the other 1/4 would have to be water, just like the human body has a lot of water.
Right, because the human body has a lot of water in it. That makes sense.
Is there anything else we're thinking about? Like, is all the dry weight carbon?
I don't think so, because there's lots of other things in a tree, like nitrogen and phosphorus and things like that.
Right. I think I looked that up. Let me look in my notes. I did. It's actually 50% of the dry weight of the tree is carbon-containing material.
Okay. So with all of those figures, you could calculate the volume of a sapling. Then you could calculate the weight. And then you could calculate how much of that weight is carbon. And so how do we associate that with the amount of CO2 absorbed?
We'll have to think about this some more.
Yeah. You know how when you look at the cross-section of a tree, it has those little rings on it?
Yeah.
I think that what that is it's the growth of the tree each year.
Oh, that's right.
Yeah, and so what we can do is we can say that each year the weight of a sapling is added onto the tree in the form of a new ring.
Okay, that makes sense. But how do we relate the carbon, the mass of carbon that's in the tree, to the CO2 that it takes up from the atmosphere?
Yeah, I think what we can do is we can look at the periodic table here. So carbon has an atomic weight of 12, and oxygen has an atomic weight of 16. So what we can do is we can form a ratio. For every 12 grams of carbon in the tree, you need 12 plus 2 times 16 grams of CO2.
Oh.